Home to a diverse yet fragile range of ecoregions, the interior of Western Canada is experiencing unprecedented change. These landscapes range from the rugged Canadian Rocky Mountains in the west, the water towers of the region's major rivers, to the rolling hills and prairies of Alberta, Saskatchewan and Manitoba in the south, and in the north to the subarctic taiga and Arctic tundra of the Yukon and Northwest Territories. The boreal forest, one of Canada's and the world's most important landscapes, stretches across the region from west to east. Each of these ecoregions plays a distinct role in the hydrological cycle, affecting precipitation and evaporation processes and the storage and movement of water throughout the area's rivers, lakes and groundwater aquifers. These magnificent landscapes are cold environments where snow, ice and frozen soils control the storage and release of water. But with some of the world's highest rates of warming, they're losing their cold. The landscapes and their rivers are changing, with melting glaciers, declining snow and ice cover, thawing frozen ground and changing water cycles. We're seeing impacts on terrestrial and aquatic ecosystems and changing extreme events, flood, drought and wildfire.
My name is John Pomeroy. I am the Canada Research Chair in Water Resources and Climate Change, Director of the Centre for Hydrology, and a member of the Global Institute for Water Security. We're now at the crown of the continent. The water from this ice field flows out to the Athabasca River, down to the Mackenzie in the north. It flows into the Saskatchewan River system, down to Hudson Bay, and the west side of it forms the Columbia River system, which flows into British Columbia and then down into the Pacific Northwest US. So water from this glacier is tremendously important to all of northwestern North America.
I'm Howard Wheater, Canada Excellence Research Chair in Water Security and Director of the Global Institute of Water Security at the University of Saskatchewan. We're here on the shores of the Saskatchewan River, which is one of the most important river basins for the prairie provinces of Western Canada. The Saskatchewan River is home to nearly 4 million Canadians and covers 400,000 square kilometres, Alberta, Saskatchewan and Manitoba. Another important river is the Mackenzie River Basin, further north, which covers nearly 2 million square kilometres and the provinces of British Columbia, Alberta and Saskatchewan, as well as the Northwest Territories and Yukon. The source water for both of these river basins comes from the Rocky Mountains, but climate warming is changing the snowpacks and melting the glaciers that feed and maintain the river flows.
Alpine areas in the Rockies have experienced substantial temperature increases and changes to the nature of precipitation. And the glaciers, which are retreating because the snowfall inputs to the glaciers are exceeded by the summer melt of the glaciers. We see evidence for this in permafrost decreases, where permafrost thaw is responding to shorter snow seasons, longer summers, and warmer temperatures. And we see this in the decline in the snow-covered period and decrease in snow cover at lower elevations. If you were traveling through the Canadian Rockies in the early 1900s, you might have had this view here of the Peyto Glacier. This photograph was taken by the Vaux family, and Henry Vaux, a descendant of the original Vauxes who took that photograph, took this photograph in 2002. Since that time has retreated further, hundreds and hundreds of meters further up. We're seeing ice losses of 5 to 6 meters of ice per year melting down every year as it is in its final decline. Sometimes it's difficult to look at temperature records and other things to get a feel for what climate change means. But when you see photographs like this, of this sort of change, just over a century, they can see that our landscape is utterly changing. And when we look forward for the next century, no vestige of the Peyto Glacier will exist. So once they start to melt and start to flow, it would take an exceptionally cold, wet period to cause a recovery. And so even the last few winters have been really snowy. These things are still retreating. It's not enough.
We are undergoing the most rapid warming of the planet's cold regions in the history of humanity.
In Western and Northern Canada, we've had tremendous warming over the last 75 years. In Northwestern Canada, winter minimum temperatures have gone up by 8 degrees, and average temperatures gone up in the region of 4 to 5 degrees. Further south here, we're seeing average temperatures going up 2 to 3 degrees, and winter minimums going up 4 to 5. So that's a tremendously fast warming. It's faster than other parts of Canada, and faster than many other parts of the world.
Across Western Canada, the minimum winter temperatures have experienced the greatest amount of warming. This has resulted in a later freeze-up and earlier snowmelt. The warming's also resulted in a greater proportion of precipitation falling as rainfall rather than snow, reducing the amount of snow depth and shortening the duration of snow cover by 1 to 2 months since the early 1970s.
In the Mackenzie, there's been more warming and exceptional winter warming of 8 degrees Celsius for minimums in that case. As a result, higher but earlier stream flows occurring in that watershed. And of course, declining permafrost and shrubification, which the spread of shrubs into the tundra holds much more snow in place and accelerates permafrost thaw, can also change stream flow.
We've certainly observed changes in the Mackenzie Basin with respect to permafrost. In the discontinuous permafrost areas around Fort Simpson and in the boreal forest around that region, there's well-documented evidence from investigators at CCRN, particularly from Wilfrid Laurier University, who spent a lot of time looking at the impacts of discontinuous permafrost and its change. So it's been noted that it's changing the hydrology. It's changing the flow pathways, and there's less and less permafrost in those regions, and that's been well documented on a few small basins.
The impacts of climate change, including permafrost thaw and other impacts, is bringing to the north a lot of uncertainty about the future availability and the future quality of water resources. The change you can almost see year to year. The climate's getting warmer, the ground is changing, the ground's subsiding, you're seeing forests turning into wetlands. It's so rapid, you just don't see that in southern Canada. And the implications of that are uncertain.
I've had the opportunity to work in sites up in the tundra, north of Inuvik, all the way down to beautiful peatland sites where permafrost thaw is impacting the way those systems are functioning. The north is warming up faster than any other place on the planet. Community members are having difficulty accessing places that they've used on the land because the land is thawing out. I'm a forest ecologist, and my research program up here in the north is focused on how climate warming is impacting northern boreal forests. And there are direct impacts of climate warming, including those of temperature and changing rain and snowfall, but also indirect effects, including thawing permafrost and changing wildfire conditions that impact what species can grow in different places and how those forests function.
I think it's really important to do this research in Canada's north because as climate change continues to influence the fire cycles, we expect to see more frequent fires. So right now we're seeing fires come through every 50 to 200 years, but we expect that to become more frequent with climate change. We want to see how the forests of the Northwest Territories are responding to severe fires. So in the boreal forest, fire is a natural process. It happens regularly, and many of the species here are adapted to it. But with a change in climate, we're seeing more frequent, more severe, and more intense wildfires. And so we want to know if the tree species and understory vegetation in the Northwest Territories is able to recover after these extreme fires.
Impacts on river flows throughout Western Canada are varying, both seasonally and regionally, due to the topography and complex and varied nature of the environmental and climatic changes. River basins in the Canadian Rockies are fed by melting summer snowfields and glaciers, and they've seen a decline in late summer stream flows, whereas in the prairies, some rivers have experienced increasing summer floods.
The South Saskatchewan River obtains roughly 80% of its water from the Rocky Mountains. And of that water, 60% approximately is snowmelt, and a smaller proportion, generally less than 3%, is ice melt from glaciers. But the snowmelt is critically important because it peaks in June at the same time as irrigation demand peaks in the prairies. And so this is right now tied in very nicely to human water use in the area. And in a similar way, the glacier melt, even though it's a small proportion overall, is important in late summer and in drought periods when other sources of water are depleted. And so then helps to reduce the variability of flows, particularly drought water flows in the Saskatchewan River system.
Most prominently in northern areas, an increase in the fall and winter discharge of many streams has been observed due to melting permafrost and its impacts in changing the connectivity of bogs and wetlands to streams. Other changes, such as the earlier timing of spring snowmelt and ice cover breakup, are clearly observed across much of the region.
There's a very vivid statistical trend of increasing earlier breakup events. So breakup has advanced by about a week in the last century, and that increase has been more significant in the last 3 decades as well. Prior to 1989, there were 2 April breakups going back to 1896, and after that year, there have been 8. Historically, there's been quite a range of breakup from April 28th to May 28th. But a couple of years ago, 2016, we had a new record. Breakup happened on April 23rd, shattering the previous record by 5 days. So it's just phenomenal. We noticed a significant warming in air temperature, and as a result of that, it's changed the river ice dynamics. The most noticeable characteristic is breakup timing and freeze-up timing.
Western Canada has experienced some of its most devastating and extreme natural disasters since the turn of the 21st century. Although such disasters have impacted the region since long before settlement, these events are becoming more frequent and widespread, setting records in terms of damage, cost, severity, and spatial extent. Millions of people have been impacted in recent years, with lives lost and billions of dollars in damage to property and infrastructure. Western Canada has experienced extreme and record-breaking fire years for 4 years in a row. Northwest Territories, 2014, Saskatchewan, 2015, Alberta, 2016, British Columbia, 2017. Drought at the turn of the millennium was Canada's most expensive disaster at that time, with drastic impacts on agriculture and the economy. Then major flooding impacted the Assiniboine River Basin in 2014 and the Saskatchewan River in 2013, with the city of Calgary underwater and severe damage and loss of life in other communities. And recent droughts have followed closely on the heels of wet years, with the most severe single-year drought in Alberta in 2015. These extremes have occurred against a backdrop of a rapidly changing environment due to climate change and human impacts of land and water management. Monitoring and diagnosing these unprecedented changes and trying to understand what the future holds for the changing environment in Western Canada's interior is key to the future security of Canada and also the world. This has exacerbated pressures on our land, water and vegetation, posing important challenges for society. How do we manage water security in the face of rapid change and uncertain water futures?